Now, the second method, uh, when dealing with the trend and random variations. So, before we just thought about random variations without trend or seasonality or cyclicality. However, in this case, we have a trend and a random variation. So, how do we treat trend? If there is a trend present in a time series, the forecasting model must account for this and cannot simply average past values. Two very common techniques will be presented here. The first is exponential smoothing with a trend, and the second is called trend projection, or simply a trend line. An extension of the exponential smoothing model that will explicitly adjust for trend is called the exponential smoothing with trend model. The idea is to develop an exponential smoothing forecast and then adjust this for trend. Two smoothing constants are used in this model, and both of these values must be between 0 and 1. The level of the forecast is adjusted by multiplying the first smoothing constant by the most recent forecast error and adding it to the previous forecast. The trend is adjusted by multiplying the second smoothing constant by the most recent error or excess amount in the trend. A higher value gives more weight to recent observations, but thus responds more quickly to changes in the patterns. There are three steps to follow with this exponential smoothing with the trend. The step first is compute smoothed forecast ft plus 1. So ft plus 1 equals fit or fit t plus alpha times yt minus fit t, um, and close the parenthesis. That's your formula. And as it says here, ft plus 1 is the forecast for the next period. fit t or fit t is forecast including trend for time period t. So forecast a plus and the trend in the time of t has to be included there, plus alpha, here's alpha, the smoothing constant, times yt, for actual demand, minus the trend, fit t, has to be calculated first. And oftentimes, when we are starting, fit t is not given, so we have to just give a fictitious number or first demand, or just estimate it and insert that into this variable. The second step is update the trend t plus 1 using tt plus 1 equals fit t plus beta times ft plus 1 minus fit t. This trend line is updated here by using fit t, and we are using beta as a constant smooth, uh, um, and smoothing constant that is related to trend, and we have to see the difference between forecast and the trend model and reflect that in your forecasting. The third step is calculate the trend adjusted exponential smoothing forecast, fit t plus 1, using this formula. So once you found ft plus 1 and t plus 1, your fit t plus 1 is, or fit t plus 1, or the next time period um, smoothing trend equals the forecast plus the next trend. You add them together, then you are completing your fit exponential smoothing uh, in this case. So a high value of beta, just like alpha, makes the forecast more responsive to changes in trend. So if trend changes quickly, then you can make it high, and then it reflects the past changes high. A low value of beta gives less weight to the recent trend and tends to smooth out the trend. So let's take an example of this analysis. So step one is to compute ft plus 1, and f2, say, is fit 1 plus alpha times y1 minus fit 1, and f fit 1 is, we are just using the previous data because we don't have it at this moment. Then that's going to be 54 plus zero point 0.3 is given as alpha here. So and then parentheses, and the actual demand at 2007 was 74 minus fit is just we chose as the same demand. So 74 is right here. Then your F2 is going to be 74, right? So that's how you calculate. It's very similar to the exponential smoothing method without trend. Um, and that's how we can find that. And then we go to step two. We need to update the trend. And we learned the formula is T2 equals T1 plus beta times F2 minus fit1. And we have just calculated the fit1, right? Fit1 is given as a 74. So we don't have to struggle with it, and we can just plug them in to this formula. Then T2 equals T1. T1 is 0 because we don't know at this point. That's why we put as 0. Plus zero point 0.4 times 74. F2, we calculated it to be 74. And then fit1 is, we chose it as a 74. So because it's a beginning point, that's why we have the same or a little bit weird result here. We have that. And the step three is calculate the trend adjusted exponential smoothing forecast ft plus 1 using this formula ft or fit2 equals f2 plus t2. So we found what f2 is and t2 is, so 74 and 0, just add them up, then you have fit2, which is 74. So if we do that for the third time period, then ft plus 1 is 75.5. That we How do we get it? Here we have the fit 2. Fit 2 is given here as a 74, right? So 74 plus zero point 0.3 times yt minus fit 2. So zero point 0.3 times yt is 79. So 79 is right here, minus 74 because fit 2 is 74 here. So if you calculate that, it's going to be 75.5. And similarly, tt plus 1 equals tt. tt, we found that it's a 0 from the previous case, plus zero point 0.4 times, because that's the beta that we chose. And then ft plus 1 is we found that it's 75.5, right? So 75.5 minus 74, that's 50 from here, and multiply by zero point 0.4, and it gives you zero point 0.6. Therefore, 75.5 plus zero point 0.6 gives you 76.1. So that's your new uh, bit 2, I'm sorry, bit 3 you found right here. And similarly, you go through the calculations, then this is going to be ft plus 1, t plus 1 column, and bit t plus 1 column right here. So that's how you can calculate, or exponential smoothing with the trend can be calculated there, and you can project it yourself.